Hello everyone, and welcome to Biostatistics course. In this chapter, we'll begin with an introduction to biostatistics, which is a very important subject for students in health and optometry fields. We'll build the foundation by understanding the basic concepts that we'll use throughout the course. In this lecture, we'll cover the research process, concepts and variables, levels of measurement, and research design. These are the basic foundations needed to understand and apply biostatistics in health sciences. Biostatistics is a branch of mathematics that deals with working with data, especially in health and biological sciences. It involves several important steps: data collection, organization, analysis, interpretation, and presentation. This means we first gather data, then arrange it, analyze it to find results, interpret what those results mean, and finally present them in a clear way. Also, the word statistics has another meaning. It can refer to numerical values that describe data or show relationships between variables. For example, the average blood pressures of patients, or the percentage of people with a certain disease. So, in simple terms, biostatistics helps us turn raw data into meaningful information that we can use in medical decision making. Let's move to an important question. What do biostatisticians study? Biostatisticians study different health-related issues using data. They may study diseases and disorders, such as diabetes or eye conditions, to understand how common they are and what factors affect them. They also study health risks associated with certain behaviors, like smoking, poor diet, or lack of physical activity. In addition, biostatisticians analyze health risks related to the environment, such as pollution, climate, or living conditions in specific area. For example, a biostatistician may study whether long screen time increases the risk of eye strain in optometry patients. In simple terms, they use data to understand what affects human health and to help improve prevention, diagnosis, and treatment. The research process is a step-by-step method used to find, evaluate, and understand information about a specific topic. In simple terms, it is a systematic way to answer questions or learn more about a problem in a scientific way. The first and most important step in the research process is identifying a problem. This means clearly defining what you want to study or investigate. For example, in health sciences, the problem could be: does prolonged screen time affect eye health? Or what factors increase the risk of hypertension? Once the problem is identified, the researcher can move to the next steps, such as collecting data and analyzing data. Now let's look at the main steps of the research process. First, choosing a topic. This means deciding what you want to study or learn more about. The topic should be clear and related to your field. Second, gathering information. In this step, we collect data and information from sources such as books, research articles, or reliable websites. Third, evaluating information. Here we check whether the information is accurate, valid, and comes from trustworthy sources. Fourth, Organizing the information. This means arranging the data in a logical and structured way so it is easy to understand and analyze. Finally, presenting results. In this step, we share our findings through a report, presentation, or research paper. Overall, this process helps us study a topic in depth and ensures that our results are accurate and reliable, especially in health and medical research. In research, two important terms we use are concepts and variables. First, concepts. These are abstract ideas or general notions that represent something in the real world. For example, concepts like happiness, education, or health cannot be measured directly, but they help us understand what we want to study. But variables, these are the measurable forms of concepts. In other words, a variable is something that can change and be measured. For example, instead of the concept health, we may measure variables like blood pressure, body temperature, or vision acuity. Similarly, age, incomes, and test scores are the variables because they differ from one person to another. So, simply put, concepts are ideas, while variables are the measurable parts of those ideas. In research, concepts become variables when we define them clearly and make them measurable. As we said before, concepts are abstract ideas, but in order to study them scientifically, we need to convert them into variables that we can observe or measure. For example, the concept of intelligence cannot be measured directly, so we use a variable like IQ score to represent and measure it. This process is very important in research because it allows us to move from general ideas to measurable data and that we can analyze. In simple terms, we turn concepts into variables so that we can study them in a scientific and practical way. In research, concepts can be divided into two main types: abstract and concrete concepts. First, abstract concepts. These are ideas that cannot be directly observed or measured. They represent general meanings such as health, happiness, or freedom. For example, in the health field, well-being is an abstract concept because it includes several aspects like physical, mental, and emotional health. Second, concrete concepts. These are things that can be observed and measured directly. They are specific and tangible. For example, body weight, blood pressure, and temperature are concrete concepts because we can measure them using tools and devices. In research, both types are very important. Abstract concepts help us understand general ideas, while concrete concepts allows us to measure and analyze data accurately. In this slide, we have types of variable. We have different types of variables, and each one has a specific role in the study. First, the independent variable. This is the variable that the researcher changes or controls to see its effect on another variable. For example, in a study about eye health, screen time can be an independent variable. Second, the dependent variable. This is the variable that we measure or observe. It depends on the independent variable. For example, vision quality, or eye strain level can be dependent variables. Third, the control variable. These are variables that we keep constant during the study so that they do not affect the results. For example, age group or lighting conditions may be controlled in an experiment. Now, variables can also be classified as quantitative and qualitative. Quantitative variables are those that can be measured or counted, such as age, weight, or height. Qualitative variables describe categories or qualities, such as gender, eye color, or type of disease. In summary, each type of variable plays an important role in organizing and analyzing research data accurately. Level of measurement refer to the different ways we classify variables based on their properties and the type of statistical analysis that can be applied to them. In simple terms, it tells us how data is measured and what kind of mathematical operations we can perform on the data. These levels were first introduced by the psychologist Stanley Smith Stevens in 1946, and they are very important in statistics and research methods because they guide us in choosing the correct analysis for our data. For example, some data can only be grouped into categories, while other data can be measured and used for calculations like averages. So understanding levels of measurement helps researchers select the correct statistical tools and avoid mistakes in data analysis. Now we will explain the 4 levels of measurement in more detail. These levels are very important in biostatistics because they determine how we can analyze and interpret data correctly. The first one, nominal level. The nominal level is the simplest level of measurement. At this level, data are used only for classification or labeling. There's no order, no ranking, and no numerical meaning. We simply group data into categories. For example, gender, such as male and female, blood groups like A, B, AB, and O, or eye color like brown, blue, or green. In this level, we cannot say one category is greater than another. The only thing we can do is count how many times each category appears, which is called frequency. So, nominal data is mainly used for grouping. The second one, ordinal level. The ordinal level is more advanced than nominal because here the data can be ordered or ranked. However, the important point is that the difference between ranks is not equal or not known. For example, in a pain scale, mild, moderate, and severe, or in exam grades A, B, C, D, we know that A is better than B, but we do not know how much better. So ordinal data gives us order, but not exact measurement of distance between values. The third one is interval level. The interval level has all the properties of ordinal data, but with no important or with one important addition. The interval between values are equal and meaningful. This means we can measure the difference between values accurately. For example, temperature in Celsius or Fahrenheit. The difference between 20 degrees Celsius and 30 degrees Celsius is the same as between 30 degrees Celsius and 40 degrees Celsius. And another example is IQ scores. However, there is no true 0 point. 0 does not mean no temperature or no intelligence. Because of this, we can use addition and subtraction, but we cannot make true ratio statement like twice as much. The last one is ratio level. The ratio level is the highest and most powerful level of measurement. It has all the properties of the interval level, but it also has a true 0 point, which means 0 represented the complete absence of the variable. For example, weight, height, age, and number of patients. At this level, all mathematical operations are possible: addition, subtraction, multiplication, and division. So we can say meaningful statement like 60 kilograms is twice as heavy as 30 kilograms, or 10 patients is half of 20 patients. Final summary. So in the summary, nominal categories only, ordinal ordered categories, interval equal intervals but not true 0, ratio equal intervals with true 0. So the understanding these levels is very important because it helps us choose the correct statistical tests and ensures accurate interpretation of research data and health sciences. In this slide, we will focus on an important idea in the levels of measurement, which is the meaning of 0. In some measurement scales, the 0 does not represent a complete absence of what we are measuring. This type of 0 is called an arbitrary 0. A good example is temperature in Celsius or Fahrenheit. If the temperature is 0 degrees, it does not mean there is no temperature or no heat. It is simply a point on the scale. In fact, temperatures can go below 0, which shows that this 0 is not a true absence of heat. Because of this, Celsius and Fahrenheit are classified as interval scale, not ratio scales. In contrast, in ratio data, we have what we call a true 0 point. A true 0 means there is a complete absence of the quantity being measured. For example, in weight, 0 kilograms means there is no weight at all. Similarly, in height, 0 means no height. And in the number of patients, 0 means no patients. This is very important because when we have a true 0, we can make meaningful comparison using multiplication and divisions. For example, we can say 20 kilograms is twice as heavy as 10 kilograms, which we cannot say in temperature data. So in summary, in interval data, 0 is arbitrary and does not mean absence. In ratio data, 0 is true and represents complete absence. This difference is very important in biostatistics because it affects how we analyze and interpret data correctly. Levels of measurement can be arranged in a hierarchical order known as Rion, which stands for ratio, interval, ordinal, and nominal. Rank it from the highest to the lowest level of measurement. This hierarchy shows that each higher level included the properties of the levels below it. For example, ratio data has all the features of interval, ordinal, and nominal data, while nominal has only basic classifications. Understanding this order is important because it helps researchers choose the appropriate statistical methods. The higher the level like ratio, the more powerful and flexible the analysis, whereas lower level like nominal are more limited. Now we'll talk about research design. Research design is the overall plan or structure of how a research study will be conducted. It is like a blueprint that guides the researcher step by step throughout the study. It explains how we will collect data, what methods we will use, and how we will analyze the data. In simple terms, research design answers the question how we will carry about or out the study from start to finish. A good research design is very important because it helps us ensure that the results are valid, reliable, and scientifically accurate. For example, in health study, the design will decide whether we use surveys, experiments, or patient records to collect data, and how we will analyze the results afterward. So, research design is the foundation that keeps the whole research process organized and scientifically correct. In this slide, we will discuss the main types of research designs. Research design is the structure of a study, and it can take different forms depending on the purpose of the research. The first one, descriptive design. Descriptive research simply describes a situation as it is, without changing anything. It answers the question, what is happening? For example, a survey asking people about their food preferences or describing the number of patients with a disease in a hospital. It does not test, cause, or change anything. It only observes and describes. The second one, experimental design. Experimental research is used to test cause and effect. In this design, the researcher changes one factor to see its effect on another factor. For example, changing a teaching method to see if it improves students' performance, or testing a new drug to see its effect on blood pressure. This is the strongest design for identifying cause and effect. The third one is correlational design. Correlational design or correlational research looks at the relationship between two or more variables. It does not change anything. It only checks if variables are related. For example, studying the relationship between sleep and health, or screen time and eye strain. It tells us whether variables are connected, but not whether one causes the other. Exploratory design or exploratory research is used when the topic is new or not well understood. It helps us explore ideas and gain initial understanding. For example, studying why a new health trend is becoming popular or exploring a new disease pattern. It is often used at the beginning of research. Cross-sectional design, cross-sectional research studies a population at one specific point in time. It is like taking a snapshot. For example, a survey for people's opinions in 2023, or measuring the prevalence of a disease in one hospital during 1 month. It is quick and useful for describing a situation at a single time. The last one, longitudinal design. Longitudinal research studies the same people or group over a long period of time. It helps us see changes over time. For example, tracking students' academic progress over 10 years, or following patients to see how a disease develops. It's very useful for studying trends and long-term effects. So in summary, descriptive equal describes. Experimental equal test, cause and effect. Correlational is studies relationships. Exploratory design is explores new topics. Cross-sectional is study at one point in a time, but longitudinal is study over time. Each design is used depending on the goal of the research study in health and medical sciences. Thank you for watching. I hope this helped. Take care and goodbye.